So today we will start the new topic, AC converters. It means we will have a AC source and we will have the AC load. And at the output, we will get a variable voltage and variable frequency. Let us start the lecture today. First, we will see the introduction, and then we will see two major types of AC to AC converters. The first one is called phase controlled AC to AC converters. And the second one is called cycle controlled or frequency controlled AC to AC converters. We can also call this as a cyclo converters. You can understand from the name itself, cyclo converters. It means it's converting the cycles of the AC input voltage. Cycle means, like we know, one cycle is having positive half cycle and a negative half cycle. So that is the one full cycle of the sinusoidal wave. That is the AC signal. So it's converting the cycles, then only we can change the frequency. And we will also see the input and output waveforms for different types of AC to AC converters. And finally, we will see one important topic today, that is VFD. So that is variable frequency drive, VFD. So this is very important actually in many industries around the world. They are using this. I think almost 65% of the applications are using this AC induction motors in their applications. So if you want to control the speed of the AC motors, then you have to control the frequency. So how can you control the frequency? That is the device called VFD. So we have to use the VFD to control the frequency and the speed of the motor, induction motor. Let's say AC induction motor. So let's start now. So as I said, like a AC voltage converter, it controls the voltage, current, and average power delivered from an AC source to an AC load. So here you can see here, this is the cyclo converter. We are applying the AC input and we are getting the AC output. But the applied input having fixed voltage and fixed frequency. For example, in Norway, we have 230 volt, 50 hertz. This is the standard in Norway. Norway and also in many countries in the world. But in USA, they use a 120 volt, 60 hertz. But here at the output, so we can change this voltage and we can also change the frequency. For example, if you want to get 440 volt, yes, it's possible. And if you want, that is called a step up cyclo converter. And if you want to step down, that is also possible. And similarly, in the 50 hertz, if you want to get 100 hertz, it's possible. Similarly, you can also get less than 50 hertz. Okay, so now we will see now, based on the power supply, we can classify into two types: single phase AC voltage controllers, three phase AC voltage controllers. So there are two types based on the applying power source. This is the input voltage. And also based on the control, we can classify into two types. First one is called phase control. So this is, we are changing the magnitude at the output. Only we are changing the magnitude at the output. So we get the variable voltage at the output. And the another type is called integral cycle control. So that is the one going to change the frequency. So two major types. One is we are controlling the phase angle. Another one is we are controlling the cycle or frequency. So these are two types, two major types of this AC to AC controller. And what is the logic behind these controllers? It's not a matter you are going to study about single phase or three phase, or you are going to use the phase control or cycle control. So you should know the logic. You have already studied about DC to DC converters and rectifiers. So how do we control the voltage at the output? So for example, we are changing the delay angle, alpha. So alpha, it's called firing angle or phase angle or delay angle. So delay angle means, for example, here we have some AC input voltage. We are applying, for example, through SCR. So we are firing the SCR only at particular alpha, particular angle. So for here we have 0 to 180 degree. So if you fire this, firing means what? First of all, firing means triggering. Just we are triggering the gate of the ACR. Then only the ACR will start to conduct. So trigger means what? Trigger means that is the large amplitude, short duration. So like this, large amplitude and short duration. So I apply this trigger signal at this point. It means I turn on the gate, then the ACR start to conduct. Then, so instead of, this is the input voltage I apply, but the output voltage only starts from here. So that is the phase angle or delay angle. So we are making some delay. So same like this. So you will have several like these pulses. And when you make the average, it's going to be less. If you apply 230 volt, if you want to get the DC volt or AC voltage at the output, it's up to the converter circuit, what you are using, then you can get the corresponding output. So this is the delay angle. That is the one logic. And another one is called switching time. So by changing the switching time or by reducing the interval between these pulses, you can change the frequency levels. We will see the example. I will show you how we can make this. How can we change the switching time? And by changing the switching time, how can you change the frequency? So you should first understand the theoretical logic. Then of course, when you do the experiment, it's easy for you to write the explanation. And definitely when we study about the theory, we are talking about ideal circuits. So, but in the lab, you are using the practical circuit design. So that's always the measurement have some differences. In ideal circuits, we assume there is no loss. Always the input impedance is 0, output impedance is infinity, and so on. But in practical, it's not like that. There is no infinity in practical. So we always have certain limitations. So the practical circuit have certain limitations. That's why the measurements are not exactly the same, but it will be almost the same or similar. Okay, so by changing the delay angle or switching time, you can change the output amplitude or output frequency. Here we want only AC instead of DC. So that is why we call this as a AC to AC controller. So it gives an effect of removing or modifying. Okay, so this is just the same. By touching these two parameters, we are removing or modifying some of the source waveform, because this is the source waveform, original waveform, the red color. We are modifying that by changing the delay angle and switching time before it reaches the load. So this is the logic. Now let's move on further. This example is just the same what I said just before. So here I had given here, you are applying the fixed voltage, fixed frequency AC input. At the output, you get variable voltage, variable frequency AC output. So in some cases, you want to change only the frequency, not the voltage, not the amplitude of the voltage. So in that case, you will have the fixed voltage, but variable frequency. But in some applications, you need both voltage and also frequency needs to be changed. So there are so many applications. They are using these AC to AC controllers. The known ones we know most of the time: compressors, conveyors. For example, in the airport, we are putting the suitcase, and the conveyor belt is taking the suitcases. So that is also using the AC induction motor. Wherever you have the AC induction motor, you need to control the speed. Either it can be a constant speed, or sometimes you want to increase the speed or slow down the speed. But for that purpose, you must need these AC to AC controllers or AC to AC converters. And also when we produce the food, this conveyor belt will be keep moving, and this machine will be putting some kind of filling. So it has to be in the uniform and automatic. So it's not like a human can do this. Like for example, if the human put this kind of fillings in one of the base, he will put more, and another one it will be less. But the machine means everything is automatically programmed, but this one should be moving in a constant speed. So after it finish few seconds filling this filling, and then it has to move out, and then this next one should come here. So that this kind of purpose, we need to sometimes control the speed. If they use this machine, This is not only for this PAS3. So they may use different products, but the same machine. So we need to control the motor speed. We also need these AC to AC controllers in that kind of applications. And also we are using in fans, pumps. We are using pumps to pump the water, and printing machines and packaging. So it's useful in quite many industries and applications. How can you implement this circuit, AC to AC controller or AC to AC converter? How can you implement the circuit? First, let us start with a simple one. First, we will see the single phase. So it's very simple circuit. By connecting anti-parallel pair of the following. Anti-parallel means one against each other. So for example, SCR and diode, you know how SCR looks like. If you put this gate terminal, then that is called SCR. And if you put like just the diode, you know, diode actually it's like this, the forward in this way. This is the anode and this is the cathode. But here I just put it in the other way. Here this is the anode and this is the cathode, because we call this as anti-parallel. They are going to be parallel to each other. You see both terminals are connected together, but they are opposite directions. So this one is towards this direction, cathode, and this cathode is towards this direction. So that is why we call this as an anti-parallel pair. Pair means two, pair of the following. So it can be SCR and diode, or it can be two SCRs. Instead of diode, you can have one more SCR here, or you can use the triac. Triac is also very similar device as the SCR. Just instead of connecting two devices, we just use a single device. We fabricate a single device. It's just like this. Triac symbol is just you put the two diodes together, the opposite. So I will show the triac circuit now in a while. So you are using these devices between the power supply and the load. Then you will have this AC to AC controller. So now just what we had seen basic introduction. What is AC to AC controllers and where do we use these AC to AC controllers, and how can we implement these AC to AC controllers? We had seen just only the idea. Now we will see the actual circuit.